Okay, we are live. Hi, everyone. Let's just wait for a minute so more people can join in, and then I'm going to begin. Okay, so I guess let's start the session. Hi, everyone. Hope you're all doing great and amazing. Welcome to the fifth episode of the Learning Series. Um, Learning Series is hosted by Pakistani Women in Computing. To all the people who are part of the Learning Series for the very first time, let me give you a brief background as to why we are hosting these series. So, Pakistani Women in Computing is basically a global community of women with the aim of collaborating, mentoring, and creating opportunities for each other. After the pandemic hit, most of us were not able to meet with any mentors from the industry or seek any advice or guidance due to lack of social gatherings and limited contact. So, learning series is essentially a way to meet your mentors from industry and academia to learn and seek advice while you're working remotely. Today's episode is hosted in collaboration with IEEE UAT Lahore Student Branch. The IEEE UAT Student Branch has been arranging technical activities and workshops to help students in their professional growth. All Pakistan Electrical Symposium is a visionary platform and a signature event of IEEE UET. The symposium actually annually brings unique ideas, and its purpose is to bridge the gap between industry and academia. This time around, the idea that they are presenting is empowering by innovation and expanding possibilities. So make sure that you guys do check out their page to stay updated with the latest events. We will also post the link of their page or any group in the comment section as well. Today's episode is about data visualization in Python. Our honorable speaker for today is Moazma Zahid. Moazma is the principal engineer manager at Microsoft Azure and has been in the tech industry for over 13 years. Her areas of interest include data, artificial intelligence, and cloud computing. She has experience with managing big data technologies and multi-cloud platforms and has implemented several innovative solutions to complex business problems. Moazma is an advocate of diversity and inclusion at the workplace and enjoys helping and empowering others via several platforms while being a firm believer in building a world of equal opportunity for all. She's also a volunteer in several organizations like Anita Bjork, Women at Microsoft, Women Who Code, and also holds the position of President for Pakistani Women in Computing. Moazma is also the proud owner of the Mentor of the Year 2020 award. So thank you so much, Moazma, for taking out time and joining us today. Why don't you give us a little background about the motivation behind preparing a session on data visualization in Python and how this will be useful for anyone who is interested in this session. So over to you, Moazma.
Thank you, Tuba. Thank you for the introduction. Thank you, IEEE, to actually be partnering with us for this event as well. So I'll start sharing my screen, and we are all going to start learning about data visualizations using Python. At any point in time during this presentation, during this session, if you have any question, please feel free to put that in the chat. I'm able to see the chat here. So Tuba and the folks from my team would be helping me to get to those questions and answer those questions for you. If I'm not able to get all the questions answered today, you can reach out to me. You can find me on LinkedIn. You can find me on Twitter. Both places, my DMs are also open, so you can reach out to me there as well, or you can reach out to me through PWIC page, and I would be more than happy to kind of get back to you with all the answers. So what I thought today to do was to, instead of having slides, I am actually going to walk through you using a notebook, which is in Python. So if you've not used notebooks before, this is a very easy tool. I know in the previous episodes of this series, we have actually done similar with using notebooks as well. So I'm using Kaggle.com. Again, if you don't know about Kaggle, it's an open source website where lots of data science competitions happen. And it's very easy way to host your notebooks and run them, and you can even run them on some GPUs as well if you want to. So instead of using my local machines, I've actually uploaded this on Kaggle because after this session, I want to make it public, and this will also be available in my GitHub, so you can find me on GitHub as well with my first name. So with that, let's get started. So the first question I have for all of you, and why I think this is a question that you can tell me that why you are here, why are you attending this session? And second question that I have for you is to kind of answer that where are you in terms of data visualizations using Python or any other tool, let's say Power BI or Tableau or any other tools that you use. Just tell me your experience level. Are you all beginners? Are you intermediate? Or let's say you are an expert in that. So please put that in the chat and keep them coming. So this does not feel like a one-way session, and it's more of a conversation. I'll repeat, I have two questions for you. One, why you are here, what do you want to learn out of this session? And the second question I have is, what is your experience level with data visualizations? So I see a lot of people are watching, a lot of people are liking, so we'll get started here. While you put that in the chat, so let's start about like why I'm talking about data visualization, especially in Python. So Python is second year in a row, it's the #1 preferred programming language in terms of data science. And there are several surveys. You can go to Stack Overflow and a few other places. If you are in the data science field or any data analytics field, Python has actually a lot of increased interest in this programming language. There are a lot of data visualizations tools that you can use. As I mentioned, there's Tableau, there's Power BI, and definitely I've used a bunch of others as well. The reason why I'm focusing this session on Python is as a data scientist, you don't need those fancy tools, let's say those third-party tools like Tableau or Power BI to actually tell a good data story. To me, data story is really, really important to convey the ideas that you have or the insights that you have from data. I know you must have all heard this term, the data is the new oil. It has been said for almost 2 years now, which means that it is the most important commodity that anybody has, any organization out in the world. Even if it's not a tech organization, data is actually increasing at a really, really fast rate. So we need to make insights of this data at a very fast pace as well, and also learn the tools and tricks to make more sense of this data. Again, I'm using Python because Python is #1 programming language used by data scientists. And in this session, I would be primarily talking about using Python to build interesting data visualizations. Again, the focus of this session is not to go into syntax because you can always look at the syntax afterwards. The idea is like, how do you choose different libraries? How do you choose different chart types? Why would you choose one versus the other? And then this is open conversation. If you have built similar charts in the past, I would really, really encourage if you can share your findings with me here, and we can all learn from your experience. I by no means am an expert in this field, but I think I really enjoy seeing a lot of great visualizations, and we go from there. So the first question a lot of people ask me, and a lot of things that I've learned over my experience of 14 plus years in this industry is, how do you choose a particular chart type? To me, it comes down to 3 basic questions. Again, #1 question, which is the most important question, is what is that story that you want to deliver? As I've said here in this workbook, that to me, data is just a story told in terms of numbers. Whenever you look at any organization, as I said, there's a bunch of data that you collect. You can tell a really good story by just looking at the data. And I'll give you a few examples of some fun projects that I've done to tell a good data story. So the first question you have to answer is like, what story are you going to tell with the data? What is the problem that you're trying to solve? And then we will start looking into different libraries, different functions, different ways to actually tell the data story. The second question is like, who are you going to present this data to? Is it to another data scientist? Is it to your manager? Is it to a business executive? What level of information do they have? Are they accustomed to, like, let's say, running certain things? more familiar to, let's say, a PDF type report or a dashboard. What is that they want to see? Because it's really, really important. And that can change the decision of which direction you go. And third, most important thing is, what is your data? Because as I said, there are so many different libraries in Python that you can use. It will depend on the types, data types, the size of the data, and the relationships between the data, how you can kind of make sense of it. So it was said, I think in the survey last year, that I think 40 or 50% of the time, data scientists, data engineers, data analysts actually spend on cleaning the data and making sense of the data and then doing everything else. So a lot of time when you get access to the data, you have to understand what the data is, what the keys are, how can you make sense of it, are there any missing values, and there's a lot of data analysis that you have to do before you can actually build anything meaningful out of it. So you'll see me sharing some of those tips here as well, so you can actually start building some great visualizations from there. So with that, let's start into, like, once you answer those questions for yourself, now the next thing I want you to think about is the selection of different charts. So there are lots of charts. So there are, I have actually top 7 types of charts here, and then my perspective on when you should use that chart versus something else. Again, it's an open discussion, so please feel free to put that in the chat, what you think and what is your experience with that. But the summary of that I want to share is that chart, the type of chart depends on what data story you want to get to. The first point is, let's say if you have a categorical data, let's say you have different business units, and then there is a data about marketing, your finance, your tech data, some budget about all of these departments. It is a great way to actually use bar charts. So bar charts are the most simplest one to create. And if you have different types of categories, and if there are more than 5, that is a good way to show. But if you have, let's say, more than 5 categories of that, you can actually look into other ways of doing that. But I think bar chart is the most simple way of creating simple categorical kind of data analysis. The second one is if you have like a nominal data. So in that case, you can use bar charts or histograms. Again, I will show you how to build those. And if your data is discrete, then it depends on that what you want to do on that case. So when the data is discrete, it makes more sense to use histograms. If it is more of a continuous, it makes more sense to use a line chart. The other few types of charts that are really used a lot is when you want to show different relationships, different patterns in the data. So in that case, a scatter plot or a bubble chart, or in some cases line chart, makes more sense. I always recommend that you try a few charts with the same data and see what makes sense to you, and maybe ask a colleague or a friend or somebody to give you feedback on that, and show them the 2 charts and say which ones makes more sense to you, which ones actually gives you more insight about, without looking into my findings, can you look at those 2 charts and tell me what do you see between those charts and how you can actually make sense of it. So those are some great ways to get feedback also. And I always build, sometimes if I'm not sure, I will build a couple of charts and just compare the 2 and try to make sense out of those 2 charts, which is more appropriate for the thing that I want to convey. In terms of volumes, if you want to compare, bubble charts are really, really great. They can easily show the difference, small versus big. Even on a map, if you want to show something which is condensed in a particular place, you can build a bubble chart on top of a map. And I will again share the examples of how you can build maps in Python as well. And again, if you want to show trends, if you want to show the patterns of data, line charts, scatter plots, bar charts, they are easy ones. Again, I'm keeping this simple and not making it over complex, because this is my philosophy. Again, you might not agree with that. To me, simple charts with a clear, concise point of what you're trying to tell with the data makes much more impact than making a very fancy dashboards, which a person, when you see, you don't really know which chart to look at. But again, going back to the question that I asked, like, who is your audience is really important. I am a data person. I'm a very analytical person, so I like to see just numbers and just very concrete charts. So that's why, to me, simple charts make more sense. But in your case, let's say if you have a business executive who likes to actually drop down and look at different things and have, let's say, lots of data visualization experience in the past, maybe you want to build a fancy dashboard with a combination charts rather than individual charts. And we're going to talk about how do you build individual charts versus a combination charts and a few others as well. So I'll leave it at that in a very high level, right? Again, this is very high level or high level introduction on different types of charts, when you should select when, and then again, more than happy to answer any questions and your thoughts on this topic as well. So I will not read through everything here. Again, as I said, this will be shared with you, so you can have this notebook ready and you can run it by yourself as well. So in terms of, as I mentioned, the top 7 types of charts are basically bar charts. There is the pie chart. Everybody loves pie charts. There is the line chart. There is histograms. There's scatter plot, and then area charts and a few combined charts. I'm not going to read through everything here, but I already summarize a high level when you should use what. Again, this will be available to you to kind of go through by yourself, like when you should choose, let's say, scatter plot versus a line chart. A simple suggestion, again, just reiterating the same thing what I just said a few minutes ago. Sometimes when you're not sure, the best thing to do is to just compare the 2 charts and ask a person, especially the person who's going to look at that report, ask their feedback on it. And before telling your insights to them, show them the charts and say, what is the insight that you got by just looking at that chart? Do you think I'm conveying the right message by building this chart or not? Because again, going back, you are trying to tell a story, and that story should be reflected in the chart that you just built. So I am not going to read through, as I said, this will be available to you when you should use when, and let's start building some charts here. The other question, which is a common question, again, before going into code here, which is being which a lot of people ask, is how do you choose which library? When Python started to become popular in the data science field, there were a few libraries that were available, and a lot of people actually use them almost for everything. But now if you look at Python, there are, I would say, a dozen different libraries, and all of them are equally beautiful and equally good to actually build really amazing charts. So how do you actually choose which one to pick up? You can choose just based on what you're more familiar with or what you've used in the past. Or the question that I like to ask is what type of, like, again, going back to the data story, and how do you want to interact with that chart? So one simple way of just kind of dividing this into different libraries is this a static plotting that you want to do, or is it a dynamic plotting? What's the difference between static and dynamic is static chart is once it's built, there is no way to kind of drill down or do anything to it. It will just show you the numbers. So for example, if you build a pie chart, you can build a static pie chart which will show the division between different, let's say the previous example of marketing, finance, IT, and all of that, and will show you different pieces of the pie, and you can put percentages over there or things like that, and that would be it. So that is a static chart. And the other type is a dynamic plotting. So dynamic plotting is where the chart, you can actually drill down, you can filter, you can actually see a section of the plot and drill down further to see more, get more insights. Those would a little bit more, they need a little bit more coding as well. But again, as I said, syntax is not a problem these days. There are like hundreds of examples available, and you can easily learn and try out with your data very fast. And I do want to recommend all of you that after this session, once this workbook is available to you, please connect it with your own data sets and start doing your own analysis and see what types of charts you build. And if you post those charts somewhere, please tag me. So I would be more than happy to take a look at that and recommend you a few ways to do it differently, or maybe I'll just say this is awesome and that's great. So now let's say you know what you're building, you know where your data is, and then you have a high level idea of who the audience is and what they like to see. So let's look into all the options that are available. As I said, there are dozens of libraries in Python that are available for you to actually build these charts or these plots. I'm going to talk about a handful of them, and I have mentioned here a few that I don't have in this workbook, but I do have links here that you can go and actually read further on that. So the data libraries that we'll cover, there are two types. Again, I'm dividing into the static ones and the dynamic ones, and the most common ones. So again, the ones that are most common, you can find help on them really easily as well. So if, let's say, you are getting an error in your chart, or you don't know like how to do this part, there is a lot of online help, and they all have their own GitHub repositories that you can post questions to. You can see lots of examples over there. Again, I have all those links here for you to go through them as well. So I'll take a pause here and see if there are any questions. Okay, I see people are introducing themselves, telling the name and the university. That's great. I see some people are beginners here. I also see that some are saying good experience with Python, and then yeah, I see one interesting question, which is about what actually data visualization is, right? So just to kind of level set that, data visualization is, let's say, taking back the same example, if you have data about your organization, let's say sales of your organization for the different types of products that you sell. So you can quickly look into that in an Excel sheet, right? And see the sales in last 6 months by different products. So let's say you sell shirts and pants and shoes. You can see their sales very quickly in an Excel sheet or something like that, in some kind of a document, and you can see what you sold. But what you will not see right away just by looking at those numbers is your sale trend going up, or is it your sale trend going down? And is there a particular category that has better sales than the other? So what data visualizations help you is to build plots, is to build like a chart. And with that chart, you can actually start seeing the trends. And again, in the examples in this workbook, I'll show you a few. So data visualization, in very simple words, is a visual way to look at data. It's a data story that you can see visually, and human beings are more prone to visual cues, and you can go from there. So let's start building some charts here. So first of all, if you've ever used any notebooks, the first thing you have to do is to import a bunch of things, right? I will quickly go over the 3 types of data sets that I'm using here as well, so you have an idea of what we are trying to build. And then I will start building some charts here. So the first thing I'm doing here is importing Pandas. Pandas is a library that is used to store data. It's very heavily used. You must have heard about data frames. If not, basically you can import any third-party file format into Pandas, and then you can start doing a lot of interesting operations on them. So in this case, what I'm doing is I'm creating a data frame called Iris. I'm actually importing a CSV file. That CSV file is right here. I can quickly show you. It has an ID column. It has basically a length column, a width column, a petal width columm, and length column. It also has the name of the species. So basically, these are different types of species, and it talks about it's kind of a flower. It talks about the different the width and length of those species, and also the sepal length and width of those. So this is a very simple file, not a very, I think it has 150 records or so, not super complicated. So I'm importing that, and in a Python notebook, if you press Shift Enter, it will just run. So I just executed this, so now I can see the data is loaded, and there I just displayed 5 records out of it. Now I want to do a quick count of this. How many species basically are there? So it seems like I have 3 types of species in this data set. Each of them has 50 records. So total, I have 150 records in this file. Each has 50 in a particular category. So this is a simple thing you can do in Pandas data frame. You can do value count by a particular category, by a particular column, and you can do any interesting thing with that. The reason why I'm doing this is to understand my data more. Again, going back to the point that I made in the start of this conversation is like you need to know your data more before you start building those charts, because Without knowing the data, there is no way that you can build an interesting data story or you can answer any interesting questions. The next thing I want to do is, this is a very interesting trick in Pandas that you can do, is you can actually quickly, based on the values of the data, you can show a gradient. So what a gradient is, if based on the color depth, you can show which one of the values or which one of the data has actually more. This is a very quick way of looking at the data. For example, in this row, you can see 4.7, although the value is really high, but this is really low as compared to the other values in the same column. So it will do a quick gradient on the data. Again, I'm just showing 10 records. So head 10 means just the 10 records. This is a quick way to just do visual. So you can do a quick summary of your data and then build a visual gradient to just see what's going on. The other trick that I really like is you can build like a bar within the Excel kind of format, within that format itself. So this is also a very neat trick for Pandas that you can do, again, using the same iris data frame. I am actually choosing the color here, which is green, and then choosing the columns on which I want to see. So you can see I did not choose this battle width, just to show that you can actually use a subset of the columns. And again, this is building a bar on top of the data itself. So just the ones that are fully filled, you can see this one, the column ends here, somewhere here. So this one is really full, which means that this is one of the highest values in this column itself. So again, this is a good way just to quickly look at the data, just to quickly see what types of values you have, and you can go from there. I know in one of the previous sessions or one of the previous episodes, we talked about this in terms of exploratory data analysis. Again, if you don't know about it, any data that you get access to, the first thing you should do is spend a bunch of time to understand that data. If you don't understand the data, what the data is, there is no actual way to make sense of it. Because if you don't understand, how can you make other people understand that data? And that's the purpose why you're building these charts and you're telling a data story. So one of my favorite libraries is Pandas data profiling one. It can really quickly create a really good report about your data. And it has a lot of information like missing values, highest values, null values, lots of those interesting things that you can do. So this is a very simple format. What you can do is you can import Pandas profiling and whatever name you want to put it in, and then I'm creating a profile report of this data frame, which is the one we just looked at, and then I'm storing it in a file. Again, this is a notebook on running on a server, so I'm storing it in a file, and you can see right now in my output, I don't have the output is empty. So I'm just going to quickly run this. It's going to run for a few seconds, and it's going to build that report, and that report should be available here. So once the report is available here, I can open it up, and I can actually see a lot more information about this data. Again, this can take a little bit of time if you have lots of records. So it seems like it's done. So let me refresh here. I have a report. Let me download it and see that. So this is the report that it created on that data. Again, I'm not going to go into every field here. This is an introductory session. I want to give lots of information in this 1 hour that we have here today, so you can learn about different techniques to learn more about your data. This is one of my most favorite one, to do data profiling on your data before you actually do anything with it. So in this case, you can see on the top, it talks about overviews, it talks about variables, it talks about missing values and some sample data. So here you can see it gives you high level observations about the data, which is like any missing values, any duplicate rows, text talks about the size. Again, this is a very small file, so it is very quick to actually build that report. It also talks about the variable like types. Since I did not define any types, I gave it a CSV file and it imported it. It actually looked into the data and it is telling me that it has two types of data types. One is numeric, so 5 columns out of the 6 columns seems like numeric, and then one of them is categorical. So if you remember in the file, I had a species column, so that was about what species of the flower they are, and then everything else is like the width, length, and the ID columns, which are numeric in nature. It also gives you by each column the distinct values, the kind of distribution, Again, I will not go into more detail. Seems like this one has more values around 3. This one does not have any values between 2 and 3. Again, this is a really, really good way to just quickly look at your data and see what types of values there are in. And it also builds really good kind of correlation charts, some, again, missing values. It also gives you some examples of the first and last few rows. So this is one of my favorite libraries. If you have never used it, definitely check it out and look at this as a starting point when you are starting your data analysis journey. Again, if you're not a data scientist, also if you're not, let's say, a data analyst, if you're just starting your journey in this career, any data that you have access to, if you can just take a subset of it, let's say if you don't want to run it for like a lot of minutes, just take a subset of that and do some analysis. Again, it will give you a lot more insights before you can actually do anything with the data. So now, let's say I know very well what the data is, what it looks like. So I want to build some charts. So in the subsequent sections, what I'm going to do is to showcase you the top 6 or 7 libraries one by one. And I will build almost the similar charts in all of those libraries. So again, you can see how you can quickly build charts using the different libraries that we talked about. And they are very easy. And again, as I said, I have examples of their links that you can go to. People have built really, really complex and beautiful charts using those libraries. And I would highly recommend you to look into those. And all of those, the code is open source as well. So you can look at the code, how people build those as well. So the first one, which is the most common and famous, I would say, is the Matlab, Matplotlib. Sorry, I can never pronounce that word. So it is a very common one. A lot of people use that. It is very simple. It's used for bar charts, histograms, line charts, scatter plots, and a few others. And it can represent your data very quickly. So for this Matlab, Matplotlib example, not Matlab, sorry. I want to show, take another data set. So again, we looked at the iris data set. The reason why I'm choosing another data set for this example is I wanted to show you more of a continuous data set rather than a discrete data set. So we talked about a discrete data set is when there's no kind of continuity between the data. So in the data above, that we talked about, there were the IDs and the length and width and things like that by species. So there was no correlation between them. The next one that I want to show you is more of a time series data. So this is a data set. Again, I will quickly show you what this is. There is a CSV file which has dates, different years and dates, and it has a popularity of how many times those terms was used in search engines. Again, this is not like a true. It's a sample data set, so I don't think it is 100% accurate. But what it is actually doing is it's talk about data science, machine learning, and deep learning, and then how common those terms were in those years. So it is more of a continuous data set. So it talks about in those dates how many times those terms were used in searches. So what I'm doing here, the first thing I'm actually going to import this into a data frame called DS. DS is whatever you want to name it. I just added DS because of data science. And you can see that it has dates, it has the categories, and then it has like the popularity of those in those dates, during those dates. Now, I want to build a chart which talks about I want to see how the popularity grew in the last few years for this, right? I want to see how popular was data science, machine learning, deep learning, and I want to do that. So very simple thing, I'm going to comment out one of the lines. You can just plot each sub-column and row in a way very fast, and I'm just going to run it, and then you can see that. Yeah. So basically what I did is right now I plotted data science and the machine learning rows of this by date. So date is actually on the x-axis, y-axis is the popularity, and then you can see starting from 2004 or something till now, there is the blue line is for data science and the orange one is for machine learning. So you can see that the popularity has really grown higher in the last few years. So why I basically commented on one line is just to show you that how simple it is to add another another data set on top of this. It can be the same data set, it can be any other data set. So you can really quickly add another data set on top of it. And I will just do shift enter again, and it will actually start building that on top of it. So now I've added the third one, which is the deep learning. And you can clearly see that deep learning was really low in the past, but recently it has gone really high. It seems like it has lots of ups and downs, but it is higher than machine learning, and it's higher than data science terms as well. So again, this is an example. You can build really fast a Matplotlib chart, which is a line chart in this case, and basically it's very fast to build. You can also define different styles. This is something fun to do. I have not seen a lot of like professional charts using this, but what I'm doing here, let me run it first so that you can see it. What I'm doing here is using the same, so basically what I'm doing here is using the same field here. I'm using a different way to represent the same thing. So I'm using the triangles, I'm using the squares, and I'm also using a simple kind of line, a reduced line, to show the same thing. You might have seen some charts doing that. It makes sense in certain situations where you want to visually differentiate between the categories. But in this example, I don't think it adds any value. To me, this line chart is enough to me to tell the growth of certain terminologies over the years. But this is something I just wanted to quickly show you so you have an idea of that. Again, this is very simple to do. I'm just taking the month column, and then basically the date column, and also the column on which I want to show. And then I'm just adding this extra way of visualization. Again, this is a syntax that is used for this, and you can basically use different types. And you can find in the documentation some other ways to do the same. You can do small circles, you can do some other ways to do this as well. The last few plots, again, they're very common. I talked about them in the start of this conversation. Scatter plot is one of my favorite ones because it can really show you visually very fast how your data is trending. So this is the example of using the three terms. I'm actually using them all together. I'm not differentiated by color here. Again, you can do that. The reason to do that here, I'll show you a separate example using another library where I'll be using that, which is even simpler to do that. So this is a very simple scatter plot on top of the same data. The last two ones are bar chart and histogram. So again, very simple one-line code. It's not super complex. I'm using the dot bar and then the two columns, and then I'm specifying the widths to be kind of 20. So this is a bar chart. It seems like it's very kind of over. I actually have zoomed in here, so let me. So yeah, the output window is basically it's limited, so you can expand that also to make it more visual. Right now, that's the problem of my output window in the screen share itself. The last chart is a histogram. So histogram is basically you do the same thing, but you define the bins, like what's the width you want to do on that. So in this case, I'm doing using just the deep learning terminology and then saying from like 0 to 100, what is the value? So it seems like there's a lot of values for deep learning between like 0 to 10. So that's one way to quickly look into as a histogram as well. Again, I will have other examples to do with the similar data sets, and then you can see how we can really make sense of this at all. So the last thing I wanted to show for this particular library is that how complex you can make a graph, right? So the same graph, when we looked at all of these graphs, to me, the line chart still makes the most sense. Maybe the next possible could be scatter plot for this particular type of data. Because it's more of a trend type data that I want to see over time. So this one makes the most sense. So now that I know that this is the one I want to go with, I can make this chart a little bit more detailed and I can add more information to that. So I'm just going to do the same chart and add more information on it. So these lines are exactly the same from the code above. I'm actually adding the labels on the x-axis and y-axis. And I'm going to add some interesting things. Again, this is something fun I'm doing. I'm writing an equation on top of the on the chart, and I am also writing something saying notice something, and I'm going to actually build an arrow on top of this and point out to the person who is looking at the chart where I see that the trend started becoming upwards. So again, since I've already looked at the data, I know this is when it starts to become popular. So I'm just taking that here, and let's run it so you can see what I'm talking about. So the same chart that I had above, now I have it this way. So basically the same trend over time. I'm talking about notice something, that this is when I see data science became less popular or like less common term, and then more specialized terms, the specialized terms like machine learning and deep learning became more popular. And that's where I'm just pointing towards a particular point where I'm saying this is when this started to make a trend. So this is again an example just to showcase you that you can actually make your person who is looking at your chart, make them point towards parts of the chart and make it more complex as you want to be. Again, as I mentioned start of this conversation, I like simple charts. I like simple to the point directed ones. But sometimes you can add this kind of information on top of the charts using the same chart to direct the attention of the person who's looking at that chart. And then I have an example. So this is the example Matplot lib library that you can go to. It has hundreds of examples of all the different types of charts that you can build with the code available there as well. So you can see that you can almost build anything that is possible using this particular library. I have that link here as well for you to kind of look into and use that for your own. So I'll take a pause here. We just talked about one library. We talked about why you should choose one chart versus the other. We also talked about different chart types. And in this example, I showed you one way of doing a chart, a line chart, how you can make it more complex. And we also talked about the data and exploratory data analysis itself, like how do you data profile, how do you make good profile of, like figure out what is in your data to make more sense of it. So I'll take a pause here and take a few questions, and then we'll move on to the next library. Are there any questions? Yeah, I see a question that I've never used Python before. I really would like to learn it. Any suggestions? So Python, as I said, is one of the most common programming languages. Even if you are not, let's say, a programmer, it's really easy to learn. It's been said like whatever you can do in, let's say, Java and C++, let's say in 50 lines, you can do it in a couple of lines in Python very easily. So it's really easy to learn. There are like hundreds of online courses on Python. Some of my favorite ones are in Udemy and LinkedIn Learning. If you go to those platforms, you can find those courses really easily. And maybe as a feedback form, like when we send links out, I can find specific courses links and send that to you as well if you want to just start from scratch and learn Python. Yeah, and somebody said YouTube is the best teacher. So yeah, there's hundreds of great videos on YouTube that you can go to and learn Python very well. It's very easy to install. I would just say, just take that plunge, just install it, write a simple code, maybe a calculator or something, and then go from there. It's really, really easy. And then the tool that I'm using here, which is Kaggle, is really like it comes, you can go and create a free profile here and start a notebook today. You don't need to wait for anything. It's totally free. Whatever I'm doing here, I'm not paying a single dollar for this or single penny for it. So Great. So let's keep going. So we have lot more libraries to cover. I know we have less than 15 minutes to go. Again, the rest of the libraries I'll just quickly go over. This would be provided to you to kind of try out by yourself. The idea of this workshop is to give you lots of different ideas, lots of different examples, lots of different types of charts, and the reasoning behind why you should do one versus the other. The next library is Seabourn. So this is one of my favorite one because it's much easier to do. Whatever you can do in other libraries in a couple of lines, you can literally do in one line in this one. It's also very visual in a sense. It's very well done. So let me run. One of the most famous charts is a heat map. Heat map is actually, you can see across data based on the color itself. Again, this data is going back to the iris data. This basically this data is actually it's not the iris data, sorry, the data science data. This is a very quick way to look at like where the most values are. So again, this is looking into the heat map across that. You can see the lighter the color, it means that it has more. It has more of that. So it seems like data science is the most one, and then this simple way of doing it. Again, you can go into this library, look at the examples, you can build really complex heat maps across your data sets. And this is one of the most common types of chart, again, to look at data visually in a grid and see which ones stand out to you in that data set. So going back to the iris data, this is a great example. This is actually a joint plot. So it's basically a combination of a scatter plot and the values itself. So it shows the length and the width. I just use the same iris data that I showed in a few minutes ago. And it shows that for this particular, most of like all the, because I did not do any subset of species, it looks like the values are kind of all over the place, but there is more around this space, around like pattern length around 6 and width around 3, 2.5 and 3 is where I see the most values. So this is just a quick way again to see certain trends or patterns in your data. Another type of data is another type of plot is called facet grid, and this one is basically just doing based on the category. So this makes more sense to me because there were 3 different types of species in the data. And now I can see that the ones on the top are this Setosa ones, and the other ones are the ones who are more in this space. So it looks like this particular species has its own type of kind of width and length. However, these other 2 have a different one. So this is again a very quick way to actually categorize it based on different categories and look at that visually to see which one makes more sense for you. The other one, boxplot, is one of the most common ones, I would say, in data science, where you are doing feature engineering. If you don't know what feature engineering is, please check out our previous session that was done by Dr. Boshanjam. She talked about feature engineering a lot, like how do you select the right features. We also have a blog on PWIC Medium blog that you can go learn about. So this is a good way to see how the data is congested, like how that is located around. So it looks like same thing that you can see from here as well, that this particular category is more between or like under 5. The other 2 are kind of scattered in these 2 categories, but you can see it more visually using this. You can see that this one stays under this one stays in this range, and this one stays in this. And this is actually doing like a congested view of the same thing. I particularly like this a lot, just to look at your data, just to see the distribution of the data, especially if you're doing any statistical analysis on your data. The next one that you can do is on top of the same plot, you can actually build the spots on that as well. I'm forgetting the exact term for it, what it is called. But basically, what I've done here is on top, basically I've combined those 2 together here, the box plot and the stir plot, and they are kind of together on the same chart. So again, it's more visual. You can see more congested in this area, less above, little more congested here. This is mostly congested in that small space. One of the other one is this violin one. This is also used a lot in feature engineering. It's a similar thing like this, but it is more kind of looked upon from your x-axis. So you can actually see this one. The reason why I like this one for this is because we are looking at petal depth and width. It actually shows that these ones looks like they are more in terms of the width. This one more on the length, and this one kind of equally divided. So this is again a good way to look into visual representation of the data. In this case, the flower data. Again, you can build similar charts like this. This is more of kind of line representation of that. Since it is not a continuous data set, it's not a line chart. It's actually called a facet grid. So you can actually build something like that here. I'm not going to go into each one of this again. You will have this workbook with you. I will just quickly show you with the Seabourn. Again, there is the example gallery where you can find hundreds of amazing charts with examples and how you can build it based on your data. So again, I'll take a pause here and take a few questions, and then we'll go into the next one. Yeah, somebody asked about the link. So yeah, the link would be shared. I will make this public, this notebook public, and I will add that to my GitHub as well. That link will be shared after the session to all of you. Great. So next library is Pandas. So a lot of people don't know. This is an interesting thing that people who have been in industry for a while, they use these third-party libraries. When I say third-party libraries, like the Matlab or Seabourn or some of the other ones that I have here, instead of using Pandas itself. So Pandas, as I said, is more of a data manipulation library. It's used to actually import data, do some manipulations on it. That's the one I use on the top to actually just quickly see the data, right? And imported the data into it. But Pandas by default actually comes with a lot of interesting plots that you can build very easily as well. So one of the one, again, going back to the same iris example, you can build a scatter plot very fast in Pandas. You can just tell the X and Y axis and then what type of plot you want to build. In this case, this is a scatter plot. So one line of code, I'm able to do something very similar that I was able to write it with the other two libraries. I was able to build a scatter plot. Again, this is introductory, so you can play around with a few things and see how that goes. The other one, the same that the box plot that I built, you can build it with Pandas as well. So in this case, I'm doing it by individual columns, by species itself. So it shows like each species as a category, and you can see that I built it across like the 4 columns. So this is, again, a simple way of doing that. Between this and the other one, I do prefer the other one, but again, it depends on what you do basically and which library you want to use. But I just wanted to show you that Pandas also has has functions that you can use to actually build that. One of the ones that a lot of people don't know is called Andrews curves. This is actually part of Pandas under plotting. It used to be tools.plotting. It recently moved into just plotting, and it's basically more of a continuous one. So now you can see by color and by species. That's the one. I've not given it any color, so it chose by default a scheme, and it's showing me the variation between the 3. Again, going back, it seems like the Setosa one is the one with less width and depth, and the other 2 ones are the ones with more. So similar representation, again, using a different library and a different chart. This is similar information as well, but now I'm using more of a parallel coordinate. So again, instead of using the values, I'm using the columns itself here. So why I'm doing that is, again, looking at the same chart in a different way and see if it makes more sense to me. To me, I think this one makes more sense. Some of you might get more insights into this, but this is, again, going back into my conversation, like who is your audience and what are they more comfortable with? So again, going into, this is the link where you can find a lot of examples of Pandas charts, and those are all, again, very easy to build. So that is another example. So I know we have less than 5 minutes to go. I have time to go beyond 1 hour. Do want to cover a few of dynamic plottings as well, because I think those are really interesting as you become, let's say, intermediate to more experience in this field, and they are also really easy to build. So, so far I'll just take a quick kind of summary of what we've talked about. We talked about why you should choose a particular particular plot, why you should do a lot of data analysis, because that is the key to actually get to it. And then we talked about different types of libraries. So far we've talked about 3. So we use Pandas, we use Seabourn, we use Matlab, and all 3 of them are static plotting. So they are static plots. Next, I want to quickly jump into dynamic plotting and show you a few of the dynamic plots that you can build. Dynamic plots, again, going back to the simple definition, those are the ones where you can interact with the plot as well. So that's the next category. So one of the dynamic library is called Bouquet, and again, they have a page. They have hundreds of amazing examples. You can really build really beautiful dashboards using this library. This one, I'm not going to go over all of this. This is an example I've taken from their documentation. This is not a code I've written by any means. This is an example. Just wanted to show how quickly you can build interactive chart. So I'm going to run it. In this one, basically, there are different drugs, and then the different level of chemicals that are used in them. And once you build this, basically, I'm storing this out in a file. Why this is stored in a file is because I'm trying to build an interactive chart. So right now, I put this, and this is the output file. It's called burton.html. You can see it's not there. I just ran it, so now it's available. So I can download it and show you this chart. Again, this is not something I've written the code for. This is the chart I just built with that line of code. This chart shows all of the different species, not the species, sorry, the different medicines, and then what is the level of ingredient in that. And this is kind of, you can zoom in, you can zoom out, you can do lots of interesting things in it. And this is this piece of code. And within this piece of code, the data is also generated in the same. So again, you will have a link to this to play around to see how that works. And it's really easy to build. One of the other ones, which is one of my favorite charts, is to actually see this. I'm storing again in a file, and it should be available here. It's called report.html. It's called rich plot. So let me show you what this is. So it's this kind of it. So I think recently I saw a lot of people using Google terms, like what was searched, let's say around COVID. They built something like this to show over the time what terms became more popular. So this is one of my favorite charts to represent data in a sense that it's very visual. Again, you can use different color schemes. I'm using Bouquet for that, the library that we are talking about, which is more interactive. This is basically a survey data and just showing how many people say that about a particular question. But you can actually build it for any search related data, any text data, anything like that. This is again a very visual plot that you can build. Again, this was maybe 20 lines of code that you can build that. You can go through that. Most of them I'm defining the colors and stuff like that. It's not rocket science. Honestly, if you have questions about it, feel free to reach out. I can explain. And when I commit it, I will add a lot of comments to it as well, so you know what I'm doing in different lines of code here as well. So yeah, that's kind of the summary of this library. Again, this one is an interactive one. You can see people have built lots of interactive charts on this one. And then there are standard examples. So this is example I just showed you, and then there is this. I think this example is the one that I just showed you. There are interactive charts that you can build with it. So if you want to see this one, let me go back. You can actually build like a dashboard with it. So this one is an interactive chart. So now you can basically do interactions with your chart. and see different date ranges, time ranges. So you can build really complex interactive charts using this library. And there's like hover data and it gives you more information. And then again, this code is available here as well, and you can quickly take a look of it, how they've built it. So this is again one of my favorite libraries to build interactive charts. When you want to build something complex, when you want to do drop downs, things like that, you can really use this one for that purpose. Okay, so just checking on the questions here as well. I will go over for another 10 minutes or so, if that is okay with the... Okay. Yeah, so if there are any questions that I need to answer, make sure I will just say, Tuba, let me know, put them on the screen. If anything, it's high priority, then I can get to them as well. Great. I'll quickly go over a couple of more libraries and then I'll get to the questions and then we'll try to wrap the session up. So the next one is Folium. I wanted to show one of the libraries for maps. Recently, a lot of people I've seen doing visualization with maps, and this is a common question people ask me, what are the few options for that? One of that library is Folium. You can really build a map really, really fast using Folium. It is, again, open source. There is a link available in this workbook that you can go to. So the first thing I'm doing, again, just with 3 lines of code, I'm actually building a street map for a particular location. This is longitude and latitude. So, and then I'm saving that in this file. So let me quickly run it. I just imported the library. I basically created a map, and then I am saving it. So it should be available in this output right now. So let me download it and show you. And it is interactive. So this is the chart I just built. It is a chart for LA for that particular one. I can zoom out, I can zoom in. It uses the standard Google Maps linkage on the back end. It's an open source library, again, built. I can zoom out, zoom in, and do different things. So with 3 lines of code, I was able to build this chart. I was able to build this basically visualization with a map on it. Nothing else. I just built a plain map on it. Now I wanted to show you how you can build something on top of this map. So the same map that I have, I'm just going to put a particular text on it. I'm going to put a tooltip on it, like something that you will go and like click, and then you will find some more information about it. And I'm going to save it again with 4 lines of code that you can do easily on top of that map. So let me run that. It finished. There should be a map 2 available here. And let me open it up. So now in the same map, I have these two pointers that I added. And one of them I said, don't click here. One I said, click here. So the one with click here, if I click, it will just give you anything you want to add. You can add a link. If let's say this is a library or your business, you can add your business information here. And as simple as that. In 4 lines of code on a particular map, you've added some interesting information. So basically, it's as simple as that. I would say, again, you can make it more complex. You can build charts on map, and you can showcase examples of how dense a particular area is. You can build like population data on maps. You can build, let's say, temperature data on maps. That's one of my favorite visualizations. I think it was called, like, I think best visualization 3 years ago, 4 years ago, that somebody built, which was about the temperature changes and the climate change in different areas on top of a map. And you can do interaction with it and see over time how that has changed, especially with the glaciers melting and all of that. That was really, really amazing visualization. So again, I wanted to just showcase you this library. There is a link available that you can go into. There's a gallery available for this as well that you can actually play around with and run and different types of plots with that. The last 2 libraries are Plotly and NetworkX. Those are also interactive one. Plotly is, again, one of my favorite one. I've done several charts with this. I'll show you a quick example after that that I've built with this. And then one of the last one is for graph data. So if you have a graph type data where you have nodes and connections, let's say a graph problem that you're trying to solve, you can use this library. So let me show you this one first, the network X one. And in this case, I'm creating the graph here itself and then just building it. It might take a few seconds to build it and run it. It's basically, it's not just the visualization library, it's a library to work with graph data. So if you have more of a graph type data where you have nodes and interaction between them and connections between them, this library can provide you lots of insights into that. So yeah, so this is the kind of graph. It just shows white color because I didn't give it yeah. So yeah, there is white here. Okay, so it shows white here, but anyways, so basically it is showing a graph. Let me remove white because you are not able to see the connections. So now it makes more sense. So basically what I just quickly built was a node and the connection between them, and then I'm just showcasing them. This type of, if you have a graph type data, you can quickly see. So let's say if you want to take LinkedIn connections data and then show how many people are, let's say, connected to a particular person and how that person is connected to the rest of the world. A lot of social media type analysis can be done using this. And you can also do some interesting projects in your university if you're doing, let's say, sorting algorithms and things like that. So this is one of like a fun kind of library to play around with, especially if you have graph type data. The last one, just going back to Plotly. So instead of like showing that here, I can show you an actual example of a data problem that I solved with this. So let me go and do that. So a couple of years back, I was actually doing analysis just for fun for a TV series called Game of Thrones. If you've not watched it, it's a show that was really popular. So I actually took the data of that. I looked at that data and just did some analysis on it, and I was trying to answer a few questions about it. This is just exploration of the data. One of the things I wanted to answer was like, does a death count has anything to do, like what is the death count in episodes? Because that show was famous for the death counts, and they actually had a lot of their famous people die on that show. So you can see there are lots of episodes with 2, 4, or 1 people dying in them. And these are notable deaths, not like the deaths in general. So it seems like there were lots of episodes with a lot of people dying. Then I wanted to see like what is the average rating of episodes. So this was a very famous show. So IMDb rating for this is really high. You can see there are a few episodes which have 4 or 4.5, but most of the average rating of episodes is above 7.5 to 10. So it just reconfirms that this show was really popular. The next thing, this is the giant plot I showed you in the previous example. I built that same thing by season using the IMDb rating, and this shows very clearly that the last season rating were really low, and the first 7 seasons the ratings were consistently in the higher quadrant, right? So this is a very good way of really seeing a real data problem, and just seeing the data to just seeing the chart that answers that question. So that was this, and then again, this is just 2 lines of code. Very simple to build using the using Seabourn here. So I'm using Seabourn, which I just talked to you about. Then I had a question just for my analysis. Does deaths have anything to do with rating? Seems like not so much. The episodes in which there were more deaths, it doesn't seem like the rating was really high on that, or vice versa. So it does not make sense that my answer to this question was like maybe not. I see there's some that dropped, but not so much. Then I also looked at like the ratings and viewer figures. Again, why I'm walking you through, I just took a random data example and used visualizations to answer the questions that I want to answer. So in this case, I'm looking at the ratings and viewer figures, how many people actually watch those episodes. You can see that the episodes with higher ratings it does not have like a direct correlation, because the last few episodes, like last few seasons, there are like 14 millions or 12 million, like there are a lot of, like it does not show that there is a direct correlation basically here. Then I just built some more things here to just see, based on the director who did that, is there any correlation? You can see these are the different directors and producers. Seems like consistently this particular combination of director and producer has shown higher, but he's the same, like this combination is the one who has the lower rating as well. So again, it's not conclusive that that's the reason. It's just because the story of that maybe was not good at the end or whatever. The last thing I wanted to show here was the plotly, and this is more of using a bubble plot. This is an interactive chart that I built. So basically, over the years, I'm just mapping it based on the original air date and then the number of seasons. So I can interact with this chart. So 2011, you can see there were about 4 million or less than 4 million viewers on it. The ratings were consistently high. 2012, consistently high. 2013, consistently high. 14, yes, but not very visible like big bubbles. It seems like it's very consistent. Same thing. But 2019 is the last season, and you can just see, although the viewership is way more, there's like 14 million or 12 million plus people who watch the show, but the ratings fell down. So this is like an interactive chart built using the same data with, I would say, 6 or 7 lines of code. So I think that's about it that I wanted to share today. This is one example. Again, it's available. This is open source. It's available in my Kaggle account that you can go into. All the code you can really see as well. All the data sets, everything that I've done here is open source. You can actually look at the code and build your own notebooks. You can copy this and then try by yourself. So at the end, I just want to kind of summarize everything that we talked about. I really want to encourage you all to take your own data sets, build some of these plots, try out some of these libraries and see what you can do. It's not super complex. I cannot emphasize enough. It's pretty simple if you can actually just understand a few lines of code and again use a platform like Kaggle, which is completely free. This whole thing that I've built is really free. You can build your own notebooks. There are hundreds of examples, a lot of complex charts that are already available. And I also have some resources for you. One of my favorite resources, that's the last thing I wanted to show, which is called Database Catalog. It talks about all of the different types of charts. And it also has examples of that. And it also has like, how do you build it? So this is one of my favorite resources. You can go on any chart. For example, let's take this one, parallel sets. You can click on it. It will show you what that chart is, how you build it, what are some of the functions, and then it also has the links to tools that you can use to build this. So it's a very useful resource to have. I'll share the link in the chat right now to all of you, so you have it. But yeah, I will share all of the links. They are in the resources as well. And that's kind of about it. I just want to end at it like, don't overclutter your data stories. Make it as simple as possible. Do what makes the most sense for you and the viewer and the person who's consuming that information. Try and keep learning, because after so many years of experience, I'm still learning a lot of these things. And every few years, there are a few new libraries also coming in that you can really learn and go from there. So again, thank you so much. And Tuba can tell me, I know we are 15 minutes over the time. If you want to take a few questions, then we can take that, or we can end the session. Okay, there are a few questions here. Let me go one by one. The first question is there any link for e-certificate or not? I think in the chat, you have to paste the information. There is a form or something that they have pasted. So if you fill that out, you will get an e-certificate. So that's the first question. The second question is, what related courses are needed in this field? So that's a great question. I think as part of like the follow-up, when I send this out, I can point you to a few courses that you can do. Data visualization itself is not a field. I would say it's a subset of the field. There are people who are really expert in just visualization. but not just Python. So if you really want to become, let's say, visualization expert, I would say look into Tableau, Power BI, and then Python also. If you want to stay a generalist, like a data scientist, a data analyst, then using Python as a data visualization is a great tool. And as I mentioned earlier on, I would be more than happy to share a few courses that you can take. A lot of the learning these days is really easy to do online. A lot of courses are available. Most of them are really like cheap or free. So I would really encourage you to do that, and I will share a few links with all of you as a follow-up. Next question. We have seen automated data visualization, simple example charts in Excel. Why should you learn to build charts ourselves? Are there any softwares that can handle big data and represent them in a lot of different ways? Yes, that's a good question. So the question about Excel, yes, Excel, you can do automated charts really fast. If you do that is great. The reason why we are doing this session specifically in Python is Python, as I said, is used for a lot of data science. So going back to that example of, let's say, the Game of Thrones analysis that you're doing, let's say you want to build a model for recommending to your viewers what type of things that they like, right? Or let's say back to the cast or the team who built that show, you want to tell them what worked, what didn't work, right? So let's say that's the problem that you're solving. So you will be using Python to actually build some forecasting models. And then again, we didn't go into the data science piece of it. You will be building some models, some predictions, some linear regression or whatever. And then you will be using Python for that. So in that example, it makes more sense to actually use Python to quickly look at the data and to visualize and then tell the data story in that same. That's where you will not like to go to Excel unless you want to do your data science in Excel, which is possible these days as well. Then you can stick with Excel. So whatever tooling you have, I think it makes sense to stay with that and build charts. Again, going back to the main reason why we are talking about Python is really popular these days. If you are in data science at one point in your life, you would definitely work on this, either Python or R. Those are the two most famous ones. And that's where I think you should learn at least the basic charts, how to build that, and they are not super complex. So there are a few lines of code. Again, depending on which team you go to, which company you go to, if they are comfortable with Excel and automated plots, then you don't need to learn it. That's fine. But I'm a learner and I continue to learn new things, especially in the data science field. There's new things coming all the time. So it's always good to know or at least have something to go back to. Yeah, I have already answered the next question, which is if you are a new person to Python, where you should start. I would share in a follow-up a few courses that you can do. I would recommend you to take a project-based approach where you take a project and try to build it with Python. And I think that would be a great way to learn Python as well. Next question, how much time does it take to be able to learn through data visualization? To able to earn through data. Okay, I think the earnings depends on, again, what you want. If you're a freelancer or let's say you're in a company, it will depend on that, right? Most of the places that I've worked in, data visualization is part of your job. So it would be part of like what you do, where you work. So what type of earnings you're thinking about. As a freelancer, there are a lot of projects just in Kaggle itself. There are lots of competition that people earn lots of money just by building that. But again, it's not just data visualization. I would just repeat that. Data visualization is a subset of this big umbrella of data science. And I would recommend you to watch the previous videos of this series that we are doing on data science. And you can actually learn about all of the different techniques of using data science, feature engineering, like what data science is, what are the different libraries, and then just start your journey there. And data visualization is a subset of it. Like once you do some data science with it, or you're trying to do data science with it, you need to visualize to make sense of it and make sense of the insights that you're bringing to the table. So I think it can take some time to start earning from it. But if you start learning a project-based approach and apply for roles that are related to that, or do freelancing for data science, I think it's really hard these days. There are a lot of jobs available in this field. Next question, is your channel available on YouTube? Yes, the PWIC channel is available on YouTube. We are live on that right now as well. So if you just search Pakistani Women in Computing, you should be able to find the YouTube link for it, and you should see past videos over there as well. We also have a Medium blog where we document everything as well. So past episodes that I talked about, they are also available there along with the examples that we talk about. I think that is the last question here. Again, thank you so much for being here. And I hope that you all learned something new today, and I hope that you will get to do more with it. I will share this notebook sometime later today for me, and we'll send a follow-up to all of you as well, so you can have it, and send some more links. Just continue learning, continue doing what you're doing, and all the best.
Thank you, Ozma, for such an insightful session. So, everyone, make sure that you guys stay tuned for the upcoming sessions. We have a variety of topics planned for the rest of the year. We have also shared the link of the feedback form in the comment section. So, do fill out the information so we can email you today's recorded session and the notebook content. You will also be sent an email before any future session as well if you fill out the form with your email and name. And if you have any suggestions about which topics you guys want to hear in future, then you can also mention that in the form. So have a great day, everyone, and see you all in the next session of the learning series. Thank you so much for joining, and hopefully you guys learned something new today. Thank you.